The very beauty of nature is its uncertain nature. You never know what is going to amaze you in the next moment. A very good afternoon to all of you. I am Adira. Universal Engineering College, Vallivattam, invites you to the international webinar series on future technologies, opportunities, and challenges after COVID 19. Thank you all for joining us for today's webinar. Today, we are going to present the topic Asset Management Digital Transformation. The presenter of the topic will be Mr. Andreas Hadjiannou. He's an entrepreneur with a B.Sc in Computer Science and Engineering and a 30-year career covering positions as software engineer, IT manager, project manager, operations director, and managing director in companies such as NCR, PepsiCo, and NetU. Currently in the managing director of virtual IT with offices in Dubai, Saudi Arabia, Qatar, and Cyprus. Extensive knowledge and experience in the initiation, organization, and management of innovative solutions with experience in ICT strategies, digital transformation, unified communication, asset management, mobility, e-business, computer-aided facility management, and smart building systems. Mr. Andreas is a national representative on the ISO 55000 Asset Management and EN 15 EN 15221 Facilities Management Standards. Now, I would like to remind you that if you have any questions during the presentation, please type them into the question box in your Zoom control panel, or you have the option of raise hand in control panel for asking your doubts. And please remind that we will also have time for questions at the end. Now we will turn the time over to respected Principal, Universal Engineering College, Dr. Joske Jacobs, sir. Please,
Thank
sir.
you, Adira. Thank you, Adira. So, good afternoon all. So, once again, welcome to Universal Engineering College, this program. So, today's presenter, one of the famous person, that is Mr. Andreas Hadjiannou. And definitely, I'm sure that today's the session will give an idea about the future opportunities about the asset management data transformation. And once again, I welcome all of you and handing over the mic to Mr. Andreas. Sir, please proceed.
Thank you very much. It is my honor to present at your college, at your University Engineering College. I had the pleasure a few years back to be there and see the premises, and was very well greeted and excellent hospitality. So I'm always, ready to assist in any kind of subject that you would like me to share. The first thing I would like to say is whatever you do in life, anything goes back to business. Business could be related to engineering, principles. Business could be related to finance. Business could be related to human resources. So technology is there to assist us to do things, but they will not do the things for us. So it is important in your studies and in your disciplines to be able to understand the environment that we are looking for. Now, as a company and as me personally, we focus on managing facility using software solutions. The core of managing any building, such as your college, even if it's related to energy management, maintenance, whatever, is the asset, okay? So the first thing I wanted to share with you is the definition of the asset management definition according to standards. Standards are very important. They are important because international standards like the ISO standards, because they have been designed or they have been put together by expertise around the world, okay? So what do? They sit around, 30, 50, 60 people, and they give their feedback. Asset management, according to the ISO 55000 standard, is all these processes that and the data and the information required to be able to manage, monitor, and maintain an organization assets life cycle. From the day you purchase them to the day you dispose them, including recycling, in the most cost-effective manner. In any organization, however big the organization is, the number one cost is personnel. The number two is assets. Assets is everything. It's buildings, floors, heating, ventilation, air conditioning, fan coil units, air handling units, furniture, computers, telephones, everything. And it's a very costly thing. Vehicles. If you don't maintain them properly, they will not last, like the cars that we have. Now, the subject of today is digital transformation of asset management, which is how do we take these processes, engineering disciplines, and business process and align them to take advantage of the digital technologies that we have today and provide to the organization the most effective and efficient management of the assets, which includes their value, which includes their continuous uptime, and includes the maintenance that we have. Before we do that, it is important to look at the standard itself. And again, it goes back to my introduction. Whatever you do, at some point, you will need to go back to your textbooks because your textbooks are based on standards, are based on a practical approach of doing things. They have been formulated by your professors, they have been formulated by your country, they have been formulated by international professors, and they are there for you to use. Yes, you need to adjust them, but we need to go back to the basics. And before I explain technologies, I need to explain, first of all, the processes of the standard, and in particularly ISO 55001, which is how do we use processes or technology to manage our assets. There are three types of things that organization like your university or any organization like Tata, for instance, will need to do. And Tata is a good example because they have buildings and they have, let's say, facilities around the world. So they need to have a policy of how they build. So recently they did a plant in the UK for designing the new Land Rovers. Okay, so Tata was involved. So there was a policy there. There is a strategy. It says that we need to have offices in Dubai. So in order to have offices in Dubai, we need to have so much space. Space is another issue that we get involved in the standard. We need to have so many desks. We need to have so many computers. We need to have air conditioning. And the planning, how this will be evolved. Okay, so all these are processes that are well defined in the standards. And as your university is now ISO 9001 certified, which is a very important certification, customers are now, when you are going out in the field, or some of you are in the field and are providing services, they expect you to follow some standard. So standards are important. We cannot use technology, we cannot converge them to digital technology unless we have a base. So our base is a standard. In our case is the 55001. The next thing is capital investment. It has to do with budget. Yes, I understand that most of you are engineers, but whatever happens, finance is going to be in your pocket. And something else that I would like to give you as a feedback. The world is changing. People are not putting let's say, they are not investing in people in finance. BP recently for their finance department, they started hiring engineers, chemical engineers, electrical engineers. Why? Because anything we do in this world is about engineering. So it is important to understand finance and combine them. The more knowledge you have, the better. Capital investment is about putting the budget for what we require in terms of purchasing. So if in a college, in your college, you will need to see the involvement, they will need to put another building next year. They have to put a budget for the building. They have to put a budget for the classes. They have to put a budget for the different hardware, even the labs they're going to put, and the new labs. All this is a budget. Once we have the budget, we need to set up the processes of how do we operate. If something goes wrong in your college and somebody has to fix it, somebody has to inform somebody that there's a problem. Now, this is one college. If you take again the Tata example, and let's say the Tata building, a huge building they have in Dubai, I'm sure that if there is a problem, somebody has to know about it. So these are operational related maintenance issues. If one room is too cold or too hot, somebody has to do something about it. I'm giving simple examples, but in essence, it could go down to more sophisticated, like there is a fire, there is a security issue, and so on. So operation and maintenance are the different processes we use to manage our assets. Life cycle is, I have bought a vehicle. What is my life cycle? I have bought a make called A and a make called B. Which of these two vehicles is good for me to maintain? Because I'm a businessman, you know, I have 100 vehicles, let's say. So I need to see which of them are more sophisticated than the others. This is called life cycle value realization, whereby which every single cost of an asset from the day you purchase to the day you dispose is entering into there and gives us a value. So to cover technology, we have what we call executive dashboards. I will show you one slide further down. But executive dashboard is a screen with different KPIs, key performance indicators, that allows us to view one of the things being this life cycle value realization. So if I have 50 vehicles of type A and with 50 vehicles of type B, I can have two KPIs and will show me the life cycle value realization of each individual of these assets, whereby which I will be able to say, this one is cost effective, this one is not, I have to change to B. In the same way, I could have what is called chillers. Chillers, as you know, are big equipment that are sitting on the roof. Some of us are using chillers, some are using VRVs, some of us are using split units. I need to be able to see this split unit I bought, is it worth it? I should buy something better. Maybe if I buy something more expensive, it will last me longer. These are processes which are built in the standard and are managed by technology. Another issue is that we need to know the shutdown. So if, for whatever reason, in your college, we need to shut down one of the labs, we need to see the effect in our operations. If in Tata, they need to shut down one of their plants, producing vehicles or producing whatever, they need to see what is the cost of this, and they need to record it. If the shutdown, and shutdown again means that we close everything, nothing is working, like what we did in COVID-19, we need to see the effect of that. So processes related to shutdown must be recorded. And then we come to the more basic. When you buy something, like an organization like Tata or an organization like your college, they don't just go out and buy something. They need to put procurement, which means they ask for quotations. They need to put specifications. Let's say they want to buy a lab tool, a microscope for the labs. they need to identify some specifications, they need to put out a tender, they need to evaluate them, they need to bring it in, they need to test it, they put it into operation. It sounds simple, but if you have a huge organization, these are not that simple. There are processes, and in a year later, or 2 years, or 5 years later, that somebody wants to find information, they have to go back and get this information. So this is called creation and acquisition processes. And then it comes to you, the engineers of the future, or current engineers. How do we fix a microscope? How do we fix a vehicle? How do we fix a computer? These are system engineering disciplines, which we have to set up. So when we say or define in the computer that in our system that a computer has a problem, we need to use some certain engineering and configuration. If an engineer goes to fix something, okay, and this equipment has been there for 5 years, I need to go and see the history. How many times we changed the motor? How many times we changed the filter? How many times we changed the hose? Everything has to be there. It's like a doctor. When you go to a doctor, it gives you, when was the last time you had a cough? When was the last time you did that? When was the last time? It's the same way we do as engineers. From the standard point of view, the standard says, if you want to be high quality related, if you want to have a high quality related environment, then you need to put these disciplines and you need to record any change you made to what else. You need to record maintenance reliability, how many times something has broken and what did you do to fix it, what spare parts you have changed, which comes to the fault and incident reports, which is every fault is recorded and is followed up to the full. If you need to dispose it, like in Europe, for instance, if you have a company in Europe, you cannot just go and take your PC and throw it away. You cannot do that. There is a process, and you have to define out of this PC what was PVC, what was iron, what was silicon, what was everything. We need to define it. So these are processes that are built into the standard. And then we go to the asset itself. What is the information you require about its asset? We will see that. How do we manage? Now we are getting more hot into the digital transformation. How do we manage our data? What databases we use? What tools we use? Who is responsible for what? The organization structure. For large organizations, we need to have responsibility. Who is responsible for the computers, which is the IT department? Who is responsible for the facilities, which is the facility or technical department, and so on. And who is using this computer? Who is using this table? Who is using this vehicle? Because if we have like a few lorries, I need to see why this lorry is spending more money on the maintenance than the other. It might be a driver. So risk management is another issue. What is the risk of a fire? Okay, whatever we do, we've seen fires left, right, and center, and especially in Dubai, we've seen fires that they will put out in less than an hour. Why? Because everything was related to a risk. So anything we put in our building, if it's a very dangerous equipment, we need to see what is the risk of something happening, both to us and our people. Performance, going back to the KPIs, we don't care just about their maintenance. We care how good they are in making sure that they are keeping our college, our company cool, and at what cost. And the whole process of supply chain management, SCM, including procurement, which is finance-related processes, but they are built into the standard. And this is something that is a cycle. And if somebody asks you what is the life cycle of an asset, according to the standard, this is it. Now, what does this have to do with technology? anything in green, we can manage using technology. But let me go one step further and explain some of these processes and break them down to their components and see how they are used in technology. So we talked about asset lifecycle. What is asset lifecycle? Is when you identify a need, I need to buy a computer. When you put your specifications, you select it, you purchase it, you install it, you operate it, and then you recycle it. It doesn't matter which of these three an organization follows. If you're going to go to a field, when you're going to manage facilities or you're going to manage assets, you have to set your customer or you have to set to your manager that you need to put a life cycle. Each of these steps is one step or one module within our system. So we have a module to enter the identification of the need, enter the design, enter to construction, commission, blah, 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 and goes forever. And then there is procurement, which again, I go to the finance and I know what I want and I do a request for an asset. In the process, so if I was to break down in asset management my procurement process or supply chain management, which is more related to consumables or related to spare parts of the equipment you are maintaining, you need to have an asset request. Again, it's a very specific functionality of a system. A purchase requisition, which will allow us to enter all the requirements that we want, including the supplier we're going to get. It gives us the opportunity to send out a request for quotation. Usually companies want about minimum three quotations. Select, create a purchase order, and then receive the assets. All these are part of a software system, and each of them have to be well defined, making sure that you are able to record them and address any reports or anything else. One example I want to mention, specifically for the asset received, is not just receiving the equipment and putting it into our operation. Healthcare. Healthcare uses equipment which are called biomedical equipment. A biomedical equipment is both electrical, electronic, computer, and sometimes mechanical. It combines all these disciplines. There are specific other international standards above ISO 55000, which guide biomedical engineers of how to manage these devices. The first thing they have to do, when an equipment goes into a hospital, they cannot use it on a patient until it goes through some specific tests. One of them is an electromagnetic test. So asset received for a hospital means we have to go into a room which is static proof, static clear. There is no any static electricity around. It's rooms that look very, sophisticated, and they look like there is all aluminum foil everywhere. They put the equipment there, they put it in operation, and they have some equipment to test it. And once that is gone, then it goes into production into the hospital. So there is authorization for anything we do. There is documents. All these are stored into our system. Moving forward, asset management systems allows you to maintain various data. Like the code, every single thing in our life is coded. You are coded, I am coded, the PC I'm using is coded, the mobile I'm looking is coded, the microphone I'm using is coded, the vehicle is coded, every single other is coded. Then we care about detailed information about the asset, what it is. So any people who is not an engineer or who is not a part of the department understand. And then we use coding to put types, like this is a furniture, this is HVAC for heating, ventilation, air conditioning, this is biomedical, this is vehicle, and so on. The connectivity, how are these connected between them? Because if the cooling of your college is not running properly, it could be that one device in the network of the devices that you have is a problem. So I need to see how they are collected. I need to see where they are located. I need to see how much it costed us to manage, to purchase, and how much to dispose it. Depreciation is about, it's a financial term, which allows us to reduce the cost of the value of an asset by the year. Today, people are leasing. You will see a lot of people, instead of buying cars, they are leasing. It's a cheaper way, short term, and you don't have to, put out a few $1,000s out at front to buy. It costs you like, a smaller amount every month, and you lease out the equipment. So you lease it for minimum years, and then you give it back. Same happens with any equipment. We even see it with one of the things that is very useful in Dubai is they are leasing generators for supporting if there is electricity down. Maintenance costs, how these costs are allocated to departments, and so on. Our purpose here is not to go into the standard. Our purpose here is to give you an introduction, to explain how we break the processes from the standard, so we are ready to use them in a technology. So the first, if you like, hint I would like to give you, or experience transfer, is that when you get an asset management system, now system, I'm using it in reference to a software, you need to put some information. Everybody would like to have all the information for whatever they have purchased, okay? Like what I showed before. But there are some minimum, there are some optimum, and there's some maximum, okay? So it is important to see what is the minimum. The minimum is every single equipment that I put, I need to know what type of equipment it is. I need to know the tag number, which is the code, the description, and where it is located. So if I have a drill, which is part of a professional drill, which is part of your labs in your college, the location will be the labs. There will be a tag number, there will be description and equipment. That will be the minimum. And the minimum is useful for equipment which are over 10 years old. Newer equipment, we need more information, like the purchase price, the purchase date, the preventive maintenance, the expected life, manufacturer, and all this. Again, this is part of the standard, but when we are actually referring for a software system, we need to be able to enter this information into there. And one major issue of any organization is asset tagging. It is the process by which we go into a building and collect all the information of an asset, which includes whatever we mentioned before, either the optimum, the ideal, the minimum, or whatever information we have. There is a process to do that. Again, I'm not going to go through that. All I want to say here is that when you collect information, you start a software system, you start digitally transforming your information by doing an asset tagging. So asset tagging is your entrance to any system, whereby which you go and do a walkthrough through a building and collect all the information. You could be using any financial system that probably has some data, any AutoCAD or CAD drawings, and then enter them into the system, into a system that is called CAFM, Computer Aided Facility Management System, or an asset management system. So before we looked into a system, we need to look at the processes, we need to look at the data structure, and we need to look at how we enter them into the system, and the process is called asset tagging. So how do we start our system? Well, we need to define coding. Everything is coded, as I mentioned before. Buildings, companies, regions, districts, and so on. So, for instance, we have your district, which is Kerala. We have your country, which is India. And under the district of Kerala, there is the Universal Engineering College, which is a facility. There are, if I remember correctly, 3 buildings. Each building has a floor. Each floor has some classrooms and departments and so on. We need to code everything. And then when we go into a system, it will look something like that, where you will have a tag number, you will have a description, the make, the model, and again, a picture. So our system will allow us to contain all the information. Our computer-aided facility or asset management system will be able to contain this information. So engineers like yourselves or your assistants will be able to maintain the information within the system. So what is a CAFM system provides? Well, we've been talking about it for half an hour now. It is the asset and the asset management and related processes. It is connected to a location. It is connected to an office, or if we are doing a new project, and then it's connected to a building. All these relationships are built under our system, whereby which I can see them using a GIS map, Global Information System map, like Google Maps, and see exactly where my asset is. I need a code and a barcode that I can identify it. I need to assign it to employee. If there is any transfer, so if you are currently using a PC and then you need to transfer it to another colleague, then there is a transfer process. There is the downtime, what status is the particular asset. If there is a problem, there should be a process where the employee can request to be fixed. A work order is the core process of any asset management or computer-aided facility management system, whereby which a problem has been identified, a service has to be assigned, a task could be a specific checklist that we need to follow to fix the task, and assigned to a technician, either an internal technician or an external technician through a contract. And then there are different quotations for doing the work, internal authorizations that need to be done. A major issue of any facility management is to do a plan for the preventive maintenance. The technology of the CAFM, computer-aided facility management, will allow you to put a plan of when everything needs to be maintained and scheduled accordingly, defining every time we do the work, the labor, that means how much time we spend, how much time it took us to go to a specific place, what material we have used, like spare parts, consumables, and what was the overall cost of the resource, the material, and the service request that we have done. These are processes that are built to the standard, but more important, they are built into our digital technology, which are defined against the budget, so we know how much we are spending. And then we make sure that we keep our end customers happy with a survey. Based on what we do on this part that you have in front of you, all of these boxes, which each individual is one function of or one module of a computerized computer-aided facility management system, we have reports which will give us idea what's happening. We have key performance indicators, which I will show in a minute. We have alerts, which means I can get an alert on my mobile that this is breaking, so I need to attend to it. We have modules to collect all the documents, like the invoices, the spreadsheets, the pictures, and associate them with my asset. We can schedule, like I want to schedule a class from 10 to 11. We have project management if I'm doing a new building or if I'm doing a new project. And all these are managed through a computerized automated facility management system, which is our asset management. Now, next phase, once we have the information of all the assets that we have based on the processes I explained, based on the data structure I explained, the world has to do with integration. And there are different ways to integrate. There is a discipline called building information modeling. Rather, it is a technology where I can, in three-dimensional mode, I can look into a model and I'm able to see how my equipment are seen in a 3D model. So our asset management connects to that system. But in order to get to a building information modeling technology, we need to start with the basics, which is our asset management standard, our data structure, a process. This is a very important point that I would like you to understand. When people come to you to sell technology, there is no technology that will automate everything. Everything has to go back to the basics. There is what is called enterprise resource planning systems. It's a finance system. So finance people, yes, you are engineers and you are managing heating, ventilation, air conditioning, whatever, equipment, but the finance wants to know what you have bought, what is it costing us, what changes are you doing to it, and so on. There are systems in the market called Building Management System, BMS, which allows you to control your environment. It allows you to take temperatures up. It allows you to shut down lights, to turn on lights. It allows you to secure locks and everything. These are managed by systems called BMS. There is also devices out there, sensors out there called IoT, the Internet of Things devices, which allows you to be able to connect to a particular device and be able to measure current, passing electric current passing through a cable, water flow on a pipe, and many other things, humidity, temperatures, light, whatever you can imagine. All these are integrated to a CAFM system, and based on the information we receive, we are able to predict some specific action to take. There are the GIS, the Global Information System, where I can see, let's say, your college from Google Maps, and I can see where each individual building is, or if you have parked vehicles where they are, or if you have equipment in a particular building, I'm able to see their location. And there is obviously nowadays the capability of using a mobile device for anything. So asset management systems allows us to integrate with equipment like mobile devices. I'm able to take, let's say, there is one of the vehicles has been had an accident. I can take the picture, I can send it to my management. My management will log it into the system, and then it will follow the process that we discussed before. I can do the same thing. You go into a class, you see a broken table, you take a picture of it, you send a request, and then somebody comes and fixes it. All this integration is done through the mobile device. And there is AutoCAD. Now, BIM is three-dimensional, AutoCAD is two-dimensional, so I can see in cross-section where everything is. Let's look at closely some of this technology. Let's say that I have a cross-section of a building, okay? Again, we are in the asset management, digital transformation, and we are showing how to transfer, how to converge our information, our asset information digitally. AutoCAD is one such tool. So digitally, I can see a cross-section of a building. I can see each of the different locations. I can see this is a conference room. I can see that I have some desks, I have some computers, I have some telephones. Each of this information, if I was able to click, if this was a live system, it will take me to a system and I will be able to see all that data structure of information that we were seeing before, but in the individual type, detail, or any other information that we want to monitor, including performance-related issue. So AutoCAD integration gives us a cross-section of our buildings, including where every single asset is. And then I can take an asset and move it somewhere else. I can see if I have space for it, and so on. I can even see where my problems is. So if there is a lot of problems here, or like where the green dot is here, means there's something wrong. I can click on it, and it will show me the problems, and then I can go into the roof and see what is the problem in the roof. As I mentioned before, BIM is building information modeling, whereby which we are able to move around in a building, click on any type of tool while I'm in the model, and it will show me all the information coming from my asset management. But in order to do that, we need to have my asset management information, and we need to have our designs designed in a BIM model. And then there are device alerts. Digital transformation of maintaining asset management includes the ability to be able to identify problems. This could be automatically come from equipment. Equipment today are very sophisticated, and they do have a small computer in there, which if they go wrong, they will send us an information. So if there's, let's say, a fault in the temperature, a fridge nowadays will send us a message using an IoT device or using a VMS system that the temperature of the fridge is going down. So it will come to my system as an alert, and then I have to continue to do something about it. I should be able to monitor any activity related to my asset using key performance indicators. So if you are out in the field, or when you go out in the field, yes, you're going to be an engineer, but as an engineer, you need to find some specific processes and some specific indicators that will tell you if something is wrong or not wrong. The standard breaks down in key performance indicator or KPIs into economical, technical, and organization. For instance, looking at my work orders, again, work orders is where a system defines what problems have been identified with a particular asset. So collectively looking at all the work orders of all the equipment will give me the failure analysis. So it will tell me how often is it failing. Is it a good air condition? Is it a good vehicle? Is it a good computer, and so on. Economical, it will tell me what is the cost of this. I bought a chair for $50, but there was another chair of $500. But maybe the chair of the $50, okay, based on a 5-year or 6-year or 10-year cost analysis is more expensive because every 6 months I have to change the chair or I have to fix it, and it's costing me more to fix it than to purchase a new one. All these KPI, which are just examples, should be managed with your KPIs. And digital transformation allows you to take information and transform it so I can see what is, let's say, the total value of my equipment for a period, what is their performance, how good are the materials I'm buying, and so on. Okay, so everything you learn in terms or everything you are going to learn in your engineering courses will be able to be managed using a system connected to an IoT device, connected to an asset. And how do they look? Well, they look as gauges, they look as graphs, they look as pie charts. So for instance, this one shows us there are so many open problems, and it is red because it seems that we have too many, open preventive maintenance schedules we need to do. So it seems that there are too many open. There are open work orders. Again, it shows us there's too many. It shows us for a period how many that we have done. All this that you see in front of you, you do not need IT knowledge, though it will be good to have somebody IT next to you to assist you in building. What you need is engineering knowledge. And we have covered from asset processes to data to systems. And this is what you need to have as a knowledge to be able to build KPIs. There are a lot of material out there about benchmarking, which is benchmarking against a specific type of, let's say, against specific type of equipment. So major manufacturers will tell you that your air condition should break once every year, and this is the problems that you might be facing. Same thing with cars. It tells you after you covered 80,000 miles, you have to change the clutch. It's the same thing with any equipment. Every 3 months, you need to change the filter. So based on this, you can define it and you can do a benchmark. So what is an IoT device? An IoT device is a sensor of any kind of sort, which could be temperature, could be energy, it could detect motion within your college, could be water detection or light or any heating, ventilation, and air conditioning monitoring, which collects this information and brings them back to a CAFM, to a computer-aided facility management, in terms of meter readings, in terms of alert, in terms of whatever we want to do. So we collect this information. And how do we collect this information? Well, we now go one step further. We've moved from the CAFM system, the Computer-Aided Facility Management and Maintenance System, or CMMS, Computerized Maintenance Management System, to a control center, to an enterprise sustainability platform. What is this? This is a particular software which is called platform because it sits on a server and it allows us to collect information from different environments. So we talked about IoT devices. The first thing that this platform will do for all the assets that we have in front of us, it will collect the information, it will use certain analytic tools, and it will provide the information to different sectors. This could be on our mobile, telling us the performance that we've seen before, telling us temperatures, telling us energy usage, and so on. So it is a very sophisticated platform to manage, excuse me, operations, to manage maintenance, and to manage energy. All this information are taken to another system or it's building sometimes within our energy management, our enterprise sustainability platform, into technologies which are called predictive analysis, whereby which, based on the information that we receive for all our assets, we are able to predict when is the next time that a particular equipment will break down. We can see interrelationship. For instance, we can see that if in a particular chiller, the motor starts using more energy, expect that it will affect the performance of our equipment. We will require to change the motor, or we will require to change specific spare parts, and so on. Predictive analysis is one tool under what you may have heard artificial intelligence, whereby which it takes the information that we have seen in platforms, it takes the information that we have seen using the integration, it takes the information that we have seen in system like that, and allows us to predict what is happening. But there is one thing that you still have to be aware, that unless you understand the business, unless you understand the engineering disciplines, unless you understand your equipment, unless you have some experience in the field, these tools will be impossible to set up, and will be probably impossible to understand. So I've tried in this 50 minutes given to pass through the different technologies. As you can imagine, it is a lot of material. My suggestion to you is to try and take each of these terminology. Google is our biggest friend in our learning process outside university. So, and during obviously your studies. So look at every single one of this terminology, and it is important to understand it before you proceed and implement digital technologies. I again want to stress that these tools are useless if you don't understand your engineering, if you don't understand the systems that you're maintaining, if you don't understand the equipment, and the bridge between technology and engineering discipline and business is standards. So do go ahead and look into the standards. Thank you very much. I am open for any type of questions.
Okay, thank you, sir. We will go ahead and take some time for questions now. Just a reminder, please be sure to type your questions into the question box in your control panel. Sir, can you see one question?
Yeah, let me just open. Okay, how your supply chain are adapting during the COVID situation, according to your company, which was the section in your company that was affected badly during COVID lockdowns, and what are the measures taken by the company to overcome those effects? Okay, that's a very good question. Now, the one thing you understand is we are not a good example because we are an IT company. So the systems that we have been using during COVID have been used within the company for years now. So we use technology which is called IP telephony, which means that our communication, because communication is a very important aspect of that, is on the mobile. So I don't care if I'm home, I don't care if I'm in the office, if I'm the college, if I am in Dubai, if I'm in Saudi, my extension still rings. So if one of my colleagues wants to find me, they just ring. So we use what is called unified communication, which is another subject if you want someday to cover. it's something that we do, unified communication. So the number one, we have used unified communication. Unified communication includes tools like the tool that you are using right now, which is the Zoom, or we call it 3CX. It has web meeting. I can take over of another customer's PC. I'm able to do chatting using my either my mobile or using my soft phone on the PC. And the next thing is that all our systems are on the cloud. That we don't have, I mean, we have some servers in our offices, but whatever we use is on the cloud. So to come back, how our supply chain management has changed, the only effect we had is delivery of products. Again, delivery of products, we don't have materials. Those that have been affected was the ones that relied on manufacturing from China or from other countries that were sort of closed, big manufacturing plants, okay? That got affected, but our supply is software. So everything is transferred to the cloud. Everything is transferred through the email or whatever. So all our people went home and they were continuing to do the work as nothing has happened, okay? So we were prepared for it, okay? But we have used technology. Let me go to the next question. Most of the companies are moving to work from home in the present situation. What is the future of facility management? Now, that's another good question. Very good question, in fact. Okay, so the tool that I've showed you before, okay, which is, let me go back and try to go back to it. The tool that I showed you before is actually answering to your question. So people are sitting, let me just bring the monitoring scheme that we have. Just bring this slide. So what I showed you about the enterprise sustainability platform, the console that I showed you before, is actually, this is where we're heading to, okay? We are heading for people to be able to utilize, this is the slide I wanted to show. This monitor is happening from everywhere. So I can be using, you know, my PC to be a part of this environment. So facility management is driving to that environment where everything is connected. Like, as I said before, all the individual new computers or new systems are coming with built-in computers, which means I can track them. I can see where they are. I can take information. I can see what is the usage of the environmental issues that are bringing CO2 or issues related to energy management, and then I can monitor and change them. So we are going to a point where everything is integrated, all the devices are connected. Let me go to the next one. What are asset management principles? Okay, asset management principles is to be able to use the first slide I showed you. Okay, again, let me move to that so I can just break that down so I can bring it easily. So asset management principles are all these. All these are asset management principles. There are the processes for budgeting. There are processes for acquiring assets. There are processes of operating, life cycle realization, fault management, and so on. In COVID situation, how lab facilities can utilize to teach students, how the practical learning can take is with those tools. Okay, now labs obviously is something that it is not possible to have access to a lab. That is limited, and the only thing I can say is to be able to show examples. Okay, so that the lab is affected in a high way, but the thing is that there are emulators of labs showing you how a particular equipment is being used. So your professors or your colleagues should be able to identify this from the manufacturers and be able to show you something, how it works using the 3D models I mentioned before. Okay, so why asset management is going digital? Okay, asset management is going digital because we need the information to maintain it. The world is running on very low profits, and all the companies are trying to make money. The only way to make money is to be able to sell more, have a better profitability, and manage their costs. Assets today are costing a lot of money. I'll give you one example. We have a customer of a bank. They have 120 bank branches. Each branch has an average of 5 split units. Now, we're talking about a lot of split units. These split units are costing a lot of money. Now, what they have identified, why they have gone asset management digital transformation, why they have gone digital, because they found that managing all these split units in these 120 branches, it was coming to a very high number, very high number. So when they put a system and they went digital, they were able to identify that the problem on each air conditioner, on each split unit, was not in, it was on a specific device. And as an engineer, you probably guessed it, it was the compressor. They have found that their cost was coming because a compressor that has reached its warranty, which is usually 2 years, and had a problem, a second problem after warranty, second problem is it continued to have several problems, which was costing them that much that it did not worth fixing it. And the system allowed them to put a principle in there, an asset management principle, whereby which any air condition which had a split unit, which the actual device, the compressor, was broken down more than once after their warranty, it should not be fixed, but it should be removed. They managed to reduce the cost by 35%. So the reason that we go digital for assets is to manage them, to be able to implement quality in an environment, and to be able to maintain them in such a way that they are cost effective. Okay, so the objectives of asset management is to be able to have cost-effective assets. So to be able to compare between different assets and see which one is more cost-effective than the other, to have quality assets that they're uptime, and to implement productivity to our people. Because if I go to an environment, it is the summer, and the air conditioning is not working, productivity of all the people working is down. So I need to be able to manage my assets in such a way that my operations are at high environment. How can I make digital transformation successfully in industry? The worldly way to make digital transformation successfully is by basing it on standards. This is my experience. Understand your engineering discipline, and then understand what the standards are referring to, because standards is like having next to you a consultant from many consultants from around the world. If you follow the standards, if you follow your knowledge on engineering and your engineering disciplines based on the manufacturer guidelines, then this is the core to successfully implementing digital transformation. Then you need to take it step by step. Projects where digital transformation was a big bang, meaning they tried to change everything digitally, they have failed, because every single element of a digital transformation technology depends on another one. So you need to have a step-by-step approach to be able to transform it. So how is digital transformation reshaping the business? Again, is allowing you to minimize the costs, increase quality, and increase productivity. which are the various positions available in the field of asset management. Okay, I will, this is a good question. I will add something to it. I will say, which are the various positions available in the field of asset management digital transformation? Okay, so let's start with the first one. The first one is consulting. Okay, you try to become asset 55,000 certified. That makes you a consultant. So you can go to companies and assist companies to become asset management oriented. Number one. Number two is to be able to get trained on CAFM technologies, computer-aided facility management. So by being able, becoming a computer-aided facility management expert with your engineering background makes you widely available into the market. Okay, so it's combining the standards, combining them with technology. Then the next technology that I would suggest that you definitely get involved is anything to do with building management systems, which again are systems that are managing buildings, they are managing, let's say, offices, they are managing and controlling HVAC equipment. So become a BMS expert, a BMS engineer. And a BMS engineer, if you search for BMS, you will find companies like Honeywell, companies like Schneider, companies like Siemens, companies like Johnson Controls. They have programs where you can become, and they have online programs. COVID-19, coming back to a previous question, has flooded the internet with webinars. So take advantage of them, and looking at this question, go ahead and look at this. Another technology that is becoming hot is BIM, Building Information Modeling. So you need to go into that and try and find ways to become a BIM expert. Energy management. This is another asset management digital transformation career that you can make, positions that you can have, because everybody wants to minimize energy. Energy is very costly. Look at the bills of the, people who manage the college will know very well. People who manage a lot of buildings will know very well. And they're everybody trying to do something more. Maybe introduce renewable energy, or maybe getting more sophisticated equipment. All this goes back to asset management principles, digital technologies, engineering principles, and knowledge about the products that you're managing. So I think we've covered all the questions. We even covered the one that is pending, why asset management going digital. Do we have any other questions?
Sir, we have a attendee to ask question. Nakul Prasad.
Yes, please.
Okay, sir. I think he can't unmute. Sir, shall we wind up?
Yeah, yes.
Okay. Thank you, sir. On behalf of Universal Engineering College, I would like to express our profound gratitude to the presenter of our 4th-day webinar series, Mr. Andreas Hadjiannou. Thank you very much for making the webinar with our participants a really successful one. We greatly appreciate the presentation you gave to us. Thank you, sir. And I also express our sincere thanks to our principal, Dr. Joske Jacob, and I'm happy to express vote of thanks to our staff members who have made this seminar a grand success. Once again, thank you, everyone. We appreciate you being here. I would like to request you all to fill the feedback form that we have sent in your mail. It will be considered as your attendance sheet. Now, I would like to remind about tomorrow's webinar. We will have Mr. Jin Matthew on the topic Digital Analytics tomorrow. Thanks again for joining us today, and we will see you next time. Stay safe, stay healthy.
Thank you very much.
Thank you very much, sir. Thank you very much for your valuable time.
My pleasure.
Yeah.
My pleasure.
See you
My pleasure.
later. Keep in touch.
Bye-bye.
Okay. So,
Bye-bye. Yes.
thank you. Thank you. Bye.